Good afternoon, everybody. Thank you very much to assist to this session for data quality to generative and non-generative artificial intelligence. In general, we are focused on generative and non-generative artificial intelligence from the point of view of their application. How can they help us? However, they mostly require data for training as an information sources. Now we need to think how these sources, information sources, data set, training data sets, impacts on the quality, the effectiveness, and efficiency of the performance of these artificial intelligence applications. So the question is, this application of the artificial intelligence can be jeopardized because of the quality of this data. And how does the data quality impact on the trustability of our artificial intelligence implementations? So here we have 6 experts dealing with these issues from different angles. So let them get us into the insights of the data quality issues. First, Rosa will talk to us about biases and over time evolution issues. Then Sebastian will tell us how standardization helps on the data quality issue. Ismael will give us a point of view of data quality methodology. Emilia will bring to us the SME's perspective. And Antonio will provide the perspective from smart cities. And finally, Jose Luis will talk to us from the large language models perspective. So first, Rosa Elvira Lillo. She is professor of statistics and operation research at the Carlos III University of Madrid. She is also the director of Big Data Research Institute, jointly funded by the Harvard University and the Santander Bank. She graduated with honors in mathematics with a PhD doctorate in this matter, and she helped us to follow up the COVID impact from 150 countries with real-time analysis of data from surveys and social media. So please, Rosa, the floor is yours.
Is the presentation okay? Yes, okay. Then thank you very much, Rosa, Ana Rosa, for inviting me to this session and to have the opportunity to discuss about this quality of data. And sincerely, I don't know at the beginning of when I prepare in this session what is the best that I can talk in this occasion. Then I prepare some slides to raise points for discussion. I hope that they don't found very light this presentation. Then the first I would like to present where I work. This is IBIDAT. IBIDAT is a research institute in the Universidad Carlos III de Madrid and in collaboration with Banco Santander. And then I think that we can add in more impact to this session because I'm the head of this institute. In what sense? Because we are an expert in multidisciplinary and excellent in research in big data application and artificial intelligence. We try to do research but motivate for real problems. And we are experts in a specialized course and in company course that the companies need to update the employers. And we are devoted to make boutique projects for companies and industrial, and we tell our public institutions, I would like to say boutique because there are many problems that the companies has that needs gray matter instead of a lot of people thinking about. We have several postdocs working in the institute that give this opportunity to the challenge problem that the companies has today. And finally, we offer as part of consortium for a European or a Spanish project. This is an imagine of part of the team. We frequently have lunch together, and as you can see, are young people, all then postdoc, and somebody are predoc. This is another photograph. And this is our coordinates in social network, where you can follow all our activities that I think that are very interesting. Now, focus on the sessions. My first point is to give a good definition of artificial intelligence. Then here I split in intelligence for humans and artificial for machines. It's so different because today I think that there is a lot of confusion about this term. What is artificial intelligence? The first approach was, can machine think? In that case, we are going to give to the machine the same faculties that human has. And then I like more the definition, can machine do what we do? This is the definition given by Alan Turing in 1950. But I appreciate more the definition given in the Dartmouth conference, in which they define the artificial intelligence as the science of getting machines to do things that will require intelligence if done by humans. This is the more close definition today are going to do with the artificial intelligence. And I like this definition that I found in the social network. AI is the 20th century parlance for doing things with computer. Now, computer as for us, as in the third industrial revolution, was the machine. It's the same. For me, it's the same. Then I have more wire about all the opportunity that the artificial intelligence has in today. Then I would like to difference between automatic learning and the usual learning based on statistical methodology. What is the difference? In the statistical methodology, we have data, we have patterns, and we have models. And with the models, we make inference and then prediction. This is very important because the focus is in the model. And now in automatic learning, we have data, more data, more data, big data, and then we have pattern and prediction. This is important for the following problem that we have with artificial intelligence. It's very well known, this phrase, garbage in, garbage out. If we have garbage in the data or we have bad model, we obtain horrible result. This is important for statistical models and for machine learning models. Then the important is the data. The data make the difference. If we have data, and also we have a lot of data, but the data has garbage, bias, and problems, the output is with garbage, bias, and problems. This is very important to have a very good point to discussion. How is the quality of the data that we have? And everything is not so pretty in artificial intelligence. We are focused on two problems. One problem is the interpretability. The interpretability of the machine learning models of algorithms that I hear in the previous session this morning that this topic appear because it's very important now. Because now we have input, we have output, and it's very well known that the deep learning algorithm is named black box. Black box because we don't know exactly how the algorithm works and how the algorithms make the prediction. And there is some fields as health and finance or bank in which they need to know why they obtain this prediction. This is explainability and interpretability. This is one of the more strong research point in my institute now. Then we need to know why the algorithm predict 22 for this data point. We need, if we are going to obtain a credit in a bank, we need to know why it's not obtained, because you need more salary, you need more change your social position, have more credit card with the institution. You need to know the motivation. And in health, it's the same. Then this is one point. And over the years, there is an increasing interest in these two topics, interpretability and explainability, because it's important for the user or the artificial intelligence. This kind of model has very good accuracy, but not has interpretability. And the other thing is fairness. This is another point very, very important for us. Fairness is now a hot topic in research, because it's very well known that the machine learning model has the advantage of the data. And if the data are biased, then predict with bias. Then, for example, this is the distribution for black and white related to the compass algorithm that give more probability to be mistreated with a higher rate of recipients by black to white. The distribution, as you can observe, is so different. This is very difficult to attack, and as mentioned, is now a very, very hot topic of research. We try to do this because here you can see if you are training the model with more with more white people, the output is related to a white people, not a black people. This is very real, and all the news are full of news about this kind of bad use of the artificial intelligence. How to attack the fairness? There are three ways to attack. In the pre-processing of the data, then you have to see if your data has this bias, and then to try to modify this bias. In the model, try to adapt the model with obviously penalize or something to make something in the functioning of the models, and in the post-processing of the output. This is the way in which we are going to attack this problem or to face this problem. Another idea is that more is not better. We are now in the era in which we think that big data is better, but in some cases we have to think about the problem. For example, we had this paper published in Nature, in which they used deep learning algorithms with a lot of parameters using neural network to predict the after-sort pattern. And 1 year later, appeared in the same journal a paper in which they obtained the same accuracy, but using a logistic regression, a basic logistic regression with 2 parameters. Then we have to stop, think about the problem, and then take decision. But because to complicate the model always is not the best option. Finally, another 2 ideas. The simplest explanation is usually the most likely, is the Occam-Razor theorem or explication, and taking care of the human capital. This phrase also appear in the session in the morning, because now we tend to think that the machines are very intelligent. I think that you have to take care of the human capital, because there is a democratization of the algorithm. You can access to the algorithm because they are in open access, but you need persons, you need people, expert people that tune this algorithm to adapt each problem, because this is the success and this is the keys of the obtain good performance. And this is all. Thank you very much.
Thank you very much, Rosa. Very interesting your explanation. So now we have Sebastian Hallensleben. He is the chair of SEMIC GTC 21, where European artificial intelligence standards to underpin European regulation are being developed, and member of the expert advisory board of the EU Standards ICT program, and chair of the Trusted Information Working Group. He co-chairs AI risk and accountability in the OECD AI, and has roles in AI committees in the Council of Europe and UNESCO. Sebastian heads digitalization and artificial intelligence at BDE, Association for Electrical, Electronic and Information Technologies, and he focuses in particular on ethics and handling the impact of generative AI, building privacy, preservancy, trust, infrastructures, as well as characteristic in quality. Sebastian, please, the room is yours.
So thank you, Rosa, for the introduction, and also thank you to the European Commission and Alexandra Balahua for the invitation to this event and the opportunity to offer a few remarks. So when we talk about data quality, why do we do so? And Rosa has already explained it very well. We do so because this is the biggest factor that we can influence in overall quality of AI systems. It's a means to an end. So when we ask ourselves, what should quality actually be? What do we need to do there? We do need to zoom out a little bit and consider the quality of AI systems, and today for this session, specifically generative AI systems such as large language models. So when we talk about standardization in the context of data quality, the first question that comes to mind is, well, what could we standardize? What can actually be the subject of standardization? And if we look on the level of an AI system, and specifically a generative AI system, it really breaks down to around 4 points. So the first point is, does that thing actually speak a language? So does it know how to speak English or German or Luxembourgish or Spanish or whatever other language we're talking about? 2, does the system know the facts? So do I have a certain degree of factual correctness in the output? That would be a quality measure. 3, is the output actually relevant to the question, to the prompt that I've provided to a model? And number 4, how good is the model or the system built around the model in enforcing certain guardrails to maybe suppress certain kinds of outputs or inputs? So those could be quality measures that you could think about standardizing. And if we look at things like even something like factual correctness, that's really, really hard to create standards for. The same for the relevance of a question. Correctness of language, yeah, that's probably a little bit easier to standardize. So the whole field of properly standardizing the quality of large language models and generative AI is a very broad and very hard one that will engage us for many years to come. In addition to those metrics, we can of course think about processes. How do we actually have good governance, good processes that make it more likely that we achieve quality, system quality, and further up the chain, data quality? That's an area where we're a lot further because it's easier to create standards for processes and for governance. And the key standard there on the international level is the ISO IC 5269. That's very mature. That's kind of almost finished in most parts. And we're using that standard also as the starting point for the discussion in Europe. Now, as Ana Rosa said, I'm chairing the committee at the European level that creates the standards to underpin the AI Act. And this is important because we have this division of labor, if you like, in Europe between regulation that sets the high-level requirements, such as transparency, quality, robustness, and standards that define one possible way to measure and to achieve those requirements. It's not binding, but it's the most accepted way that comes with a presumption of conformity. And so we really have to ask ourselves, well, what are the quality standards that we have to build at the European level, in addition to what's already there internationally, to support the AI Act. And the 5269 is quite strong in governance and process descriptions, maybe even a bit too strong, but it's very, very light on metrics. So yeah, it says, make sure you haven't got bias, but it stops there. It doesn't really tell you how you measure it and what is acceptable and how you deal with it. So within JTC 21, this is the main direction of work that we are taking. There's a technical report. There's a group that's already been working on it for quite some time. Emilia has also been involved, and I think will provide a few more details on this. I'd like to conclude this little walk around with a word of warning. When we talk about regulation and standardization of AI, and when we talk about increasing the quality and reducing risks, it's not enough to just regulate or standardize AI. In many areas, in particular in generative AI, the solutions are outside. They are quite literally out of the box. So we're not going to mitigate the impact of generative AI, the potential to create fakes at scale, only by regulating generative AI or by standardizing generative AI. We're going to address that issue by looking much more broadly at the fabric of trust in the digital space, the way that trust is emerging, can be safeguarded, can be guaranteed and demonstrated. But that is probably a topic for another conference. Thank you very much.
Thank you very much, Sebastian. So now, sorry. Ismael Caballero received his MSc and PhD degree in computer science in the Spanish University of Castilla-La Mancha. He works as associate professor in the Information System and Technologies department at the university, and he was appointed as a training head of spin-off DQ team 6 years ago. Ismael holds several certificates, CISA by ISECA, CD01 by Waldmermit, MIT, and CDMM by DEMA. He has participated in the development of several international standards, such as ISO 8060 series, leading the project for the 62, and national standards such as EUINE from 0077 to 0081. His research interests are focused on data quality management and data governance. Please, Ismael.
Thank you very much for the presentation, for the introduction, Ana Rosa. Thank you to the organization for the invitation to be here. And now I'm going to try to go a further step about what our previous speaker Sebastian has been said, right? Which is the relationship between data quality and AI, right? Yesterday, I had the chance to read a paper in which they compare AI like Superman and data quality with kryptonite, right? So the simile can be very interesting, right? So the point I want to raise is just data quality goes beyond something different from technical issue, technical concern, right? In another paper that I have just read this morning by Tom Davenport, published in Forbes, he said that there are a lot of things to do with regard to assuring an appropriate way of working for generative AI, right? And one of the points was the process view, and this is what I want to speak about, right? So we feel that it's not enough with considering data quality as just a punctual problem, because it's a matter it's an organizational matter, right? And the way, the way we can focus the organizational matter is by means of process, by means of the definition of process, right? In the series, in the ISO 8060 series, we deal with a set of different data quality management process which covers several parts of the organization and involve different stakeholders, right? So considering this process approach, I want you to think about the idea of how about doing something to manage data quality from a wider point of view. I'm trying to say that data quality goes beyond data cleansing, data profiling. It goes beyond that. Sebastian has said that in 52, 59, they are working very hard in the definition of different metrics, and this is quite a problem. Just to define a problem, to define a metric, to measure, establish the measurement method for the metrics, and to understand the meaning of the metrics, right? So this is only can be done from an organizational point of view, with the participation of different people working at business, people working at the IT level, right? So this is my point. Do you think, or just to think, right? Do you feel that data quality management goes something beyond to this specific technical operation with data? What do you think, right? We don't have here red card and green card, but we can discuss and then we can have the chance, right? In this sense, I would like to point just one last thing. People, we need references. We need references, and standards are very good references. At an international level, we have developed several international standards related to data quality management, right? And I would like to point that here in Spain, we are making a lot of effort to produce some specific standards related to data governance, data quality management, and data management. So in this sense, the data office from the Ministry of Economic Affairs and Digital Transformation, he has been supported this idea, and they have collaborated with UNE, to produce 5 specific technical specifications called UNN 77, 78, 79, 80, and 81, right? So you can download for free from the website of UNE and take a view, and so you can check what we are saying. Can really face data quality management like a set of integrative processes, right? So this is my 2 cents.
Thank you very much.
Thank you.
Thank you very much, Ismael. And now Dr. Emilia Tantar has an impressive background on artificial intelligence. She is Chief Data and AI Officer at Black Swan Lux, and a spin-off of the University of Luxembourg. She co-founded. She is also co-chair of the EU Digital SME and Alliance. She is focused on the artificial intelligence group, part of the committees on artificial intelligence at Romania and in Luxembourg for shaping their national strategies on AI, an expert representative and convener of the European SEN and SEMIC GTC 21. She is Forbes Ignite contributor, a Springer editor, author of many journal papers and scientific articles, collaborated with European and international entities, and a TEDx speaker. She also acts as reviewer and evaluator for the European Commission. Please, Emilia, the floor is yours.
Thank you, Ana Rosa, for the invitation and for the kind introduction. And thank you to the organizer, the European Commission, Alexandra, for organizing this nice exchange panel and bringing us all together. I will present here my view which comes from 15 years of research in academic setting and then spinning off from the university and being active in the public sector. I do mention that I was also active in C-level position in public agency and corporate institutions, so I have that view. That's my perspective. What I will share with you is, what I will share with you is the view of the SMEs. I'm representing in standardization the small business standards as an expert. We are 4 to 5 million small businesses in Europe, and we have one representative, one voice, and that's me. And I'm also head of delegation for Luxembourg in standardization, just to give the context. In the context of the European Digital SME Alliance, this is the group which reunites 45,000 SMEs in Europe, which are digitally active. We have also this focus group on AI. And there we have many forerunners, we call them, which are university spin-offs, which are researchers, private research laboratories, which do AI since many years, more than 15, more than 20 for some, when we didn't call it artificial intelligence. On that context, we shaped a position paper when we had the Artificial Intelligence Act, which uses data, so we go to data quality. Don't be worried that it's the same session. There we had, in the position paper, we had a specific mention on data quality for large language model. And I will focus in sharing what we had as conclusion of our survey and of our collective reasoning. We consider that large language models, they are not new. They are new bases of data which are now available to all, isn't it? To all in the large sense. Now, what we identify as challenge for the large language model comes from the data quality. And I will start with the challenges. The large language models in the generative AI in general, okay, what we'll have as general purpose AI, they bring this transformation of data into information. We have the cleaning, it was mentioned previously, and we have then the position into context, which makes it knowledge. So we are treating data quality, but we could as well consider knowledge quality. As small businesses, we are one part of this artificial intelligence value chain. We start with data, cleaning, and so on. So there are many actors. We do not act in isolation. We need interoperability with all the other actors that we interface, and we need to learn from them. When we speak about these large deposits of knowledge, which are large language models and what is generated by generative AI and so on and so forth, we know that economically, a small business will not have the capacity of building its own large language model. But if we take knowledge, how it was built in the old times, I come from Luxembourg, and in Luxembourg we were among the first in the Abbey of Echternach to have printed paper. No? That's knowledge. Knowledge which is a common understanding. Written knowledge allows us to have a vocabulary. The same happens now. We have large knowledge bases. Where do we put quality? Where do we put trust? And I would say that trust goes beyond the quality of those large language models which are built by other players on the market. It can be public institutions or it can be large economical actors. Can we as an SME ask those actors to reinforce their quality management system and risk management systems? Because we speak about this layer of trust, which is Artificial Intelligence Act, which is a framework. But that framework is a legislative framework. And in the previous session, there was this bridge between the legislative framework and the technical framework. And as Mr. Chair from GDC 21, since I elect GDC 21, Mr. Sebastian Hallensleben mentioned, the European Commission, through the, let's say, the EU Lex 2051 from 2012, has an agreement, a framework of agreement, that for all legal acts, and maybe I'm not using the right term acts, please correct me if that's not the right one. For all the legal frameworks, the technical specification should come from European standardization bodies, CEN, CENELEC, and ETSI. This is Article 4. We received a standardization request. And this standardization request, I will go a little bit in detail, but Sebastian will provide more on that. It includes, among others, requirement number 2, which is data quality. So this is the bridge. We have legal text and technical specification. There is a request. What we face as small businesses in participating in standardization for this data quality layer is the fact that we are underrepresented. We represent more than 90% of companies in Europe, but our representation is really scarce. Why? Because this is a cost. For any small company participating in standardization which doesn't have a clear feedback in the short run, it's a cost. And not everyone could afford. We have this representation for small business standards, European Digital SME Alliance, but it is a cost. So that's a risk that we perceive, our representation there. Another risk is that the other players which provide in the value chain knowledge bases, they will not ensure the elements of compliance. When we speak about the Act, we speak about compliance to that Act, and this is conformity assessment for these 10 requirements. We are studying that, and that was mentioned. We have a technical report on the challenges of applying conformity assessment for AI system, including data quality. Among those challenges, there are, of course, the sectorial challenges, but also the lack, for the moment, of standards which will be accessible to all and which will be operational. When we speak about SMEs, we speak access to market, and that's products which have CE marking. How do you achieve CE marking? You achieve CE marking through conformity assessment of level 3, which is certification. And how do you reach certification? There are two main components: quality management system and risk management systems. And we can't assure for all the stakeholders that we are interacting the quality management system and the risk management system. And can we ask if there is no legislative framework? You should ensure that, because if not, it's a huge risk for us. And data quality plays, why it is also a risk? Because if we have, for example, a system which is trained and it has poisoning attacks. What is poisoning attacks? You have a small image, which is a noise, which is included in the training data set, and which will change the meaning of the images which are used. For example, you can have other types of adversarial attacks and so on, which are on the data quality, but we can't ensure if we are using this kind of large language models. And I would stop here because I think I finished my time, isn't it? And we can continue later. Thank you.
Thank you very much, Emilia. And then we have Antonio de la Paz, has a degree in computer science by Polytechnic University of Madrid, and he is member of the Information Technology Corps of the General State Administration of Spain. He has developed his professional career in different positions in IBM, Bank Interbank, the Spanish Tax Agency, IT Department, the Spanish Energy and Environment Research Center, and several Spanish ministries, and now at the Madrid City Council. His current responsibilities is overseeing the implementation of the City Council Digital Transformation Strategy, focusing mainly on the data and artificial intelligence axis of the strategy. Antonio, the floor is yours.
Okay, thank you very much, and thank you for inviting me to this meeting. Okay, and thank you everybody is here listening to us. Okay, when I started to prepare this presentation, okay, we are talking about, I go back, okay, interoperable and age of AA. Okay, why not? Okay, go ahead. IoT city. Why? Okay, I think in this case of use, you can apply these two concepts: interoperability and artificial intelligence. I think it's a really good example of how is so important the data quality, how important is interoperability, and how Sebastian says have used a common language from the beginning. Okay, we started from the beginning, and okay, we live in Madrid. Well, I live in Madrid. We have many projects relative to IoT, and the problem is there are many companies that give services for the city hall and have their own IoT elements. Okay, what happens in IoT? Okay, you can one vertical, relative, for example, for collect garbage. But what happens if you want to share this information when IoT item that are relative, for example, for the amount of rain? They can't speak it together. So this is a problem of language, as Sebastian had told. We are looking after a common language and interoperable language between these different IoT. Okay, we have a collaboration with Polytechnic University of Madrid. We created IoT Mad Lab. We are looking after this common language where every IoT element of the city can speak with another and in an edge level. We are looking after. Okay. Okay. Next problem is modification and distortion of reality. Okay. What happens in IoT world that if you modify something in the border, okay, they have immediate consequences. Okay. Doesn't matter if someone move a container from one side to another. Okay. doesn't matter. Okay, you have to locate in another place. But what happens if an IoT detect that traffic light doesn't work or don't work correctly, or you don't receive the information from this traffic light? Okay, this is something quite important: modification and distortion of reality. Okay, you have talked about distortion of reality about ChatGPT or things like this, but this also happened in this world. Integrity and security. Okay, this is something quite important for us. Okay, this is why involved in this project to the SOC, okay, the cybersecurity unit inside the City Hall, because for us it's quite important to assure that information that produced in the source arrives in the same way to the destination. Because if we don't assure this, it's quite difficult to assure that information that we have or the data we have is correct, or at least is the same that we produce in the origin. Another, okay, I go back to security. Okay, I only assist to two of the meeting this morning, but I don't hear this word in just only once, and for us it's quite important. I think that everybody had to, in the case of IoT, it's quite important. It's transversal to all the process. Something relative, I think we have to focus on this because everything that happens in a city is related to one location. For us, geodata is quite important in all the processes and all the data that we get from the city. Okay, we have to focus on this because, okay, I know, let's make a joke about this. Okay, two things is inside the City Hall, because it's one data and half a geodata. This is a half a data. You have here maybe. Okay, analyzing this, okay, this is quite important for us to have every data that we get. You have to be associated for one position in the map. And the last, but not the least, okay, is data quality. We have talked about the GIGO, garbage in, garbage out. Of course, we agree it's also happening in the IoT world. If we don't have data, we have bad data. We have a meter in one side we don't do its work correctly. We have a problem to analyze and to produce information. Of course, IoT and IA. Okay, I think it's a really good combination. I've had to work for this. But we don't have to forget we are civil servants and we work for our citizens. This is quite important for us. Okay, if we do this, it's not for its cool or we have we use IA. We have to have a purpose to this. Our boss is here. Told us technology is a media. It's not the end. Okay, this is quite important for us. We work in this line all the time. Of course, we are using many services IA. So this is one case we are gonna work on to apply IA. At the end, we are gonna some items where we can use. We think we can use IA to improve our challenges. Okay, and the last for this. Okay, if we use this information from the city or from if we don't have good data, quality data, and correct and accurate data, you can make bad decisions. This is quite important. Okay? You have to control all this process to try to that doesn't happen. No? And at the end, okay, I don't have the solution. Sorry, I would like, but I don't like the solution. These are the challenge. In our case, on the IoT city, it is data variety. Okay, we have a lot of IoT elements that produce a completely different kind of data. Data volume, of course. You can imagine a city like Madrid, okay, where we have 3.5 inhabitants. So you can imagine the elements of city that can produce information in real time, many times. So we have to manage this. Real time, as I said, and data anomalies. Okay, this is related to data quality. What happens if I don't have the data? What happens if the data is out of range? What happens if something is not possible but is happening? What can I do? Okay, if for somebody rain a lot in one part of the city, nobody advised about this, what can I do? Is this wrong or I had to do something? This is quite important. And these are examples about data quality strategies where we can use IA to help us to avoid this. Data preprocessing, of course, but that's something that I'm going to point about this DQ strategies. We are talking about process of IA that we run in the cloud. The problem with IoT that we have to process this information in real time and as soon as possible and as close at the item as possible. I think this is a really, really big challenge relative to apply IA to IoT. Thank you very much.
Thank you very much, Antonio. And then, José Luis Calvo is a co-founder and the director of artificial intelligence at Die Berger. He began his professional journey as director of software development at Adecco. He then dedicated 15 years to Microsoft, where he held various roles, including overseeing solutions for banking and insurance. During this time, he remained closely aligned with the research division, and subsequent positions include serving as Director of Technological Innovation at MAFRE and the Director of Artificial Intelligence at Singular. José Luis frequently contributes to digital transformation, innovation, and artificial intelligence programs at universities, and his educational credentials include a diploma in information technology from University of Cambridge and Master's in Information Systems Management from EA Business School. He graduated with honors for both institutions. José Luis, the floor is yours.
Thank you very much, Ana Rosa. Good afternoon. My objective for those minutes is just to go to the ground. I mean, it's just explaining how those new models, the ChatGPT models, are working. Because I believe that for many of the discussion after that and the conclusions or makes sense to understand a little bit. So the first is that LLM is the technology that is underlying the ChatGPT. ChatGPT is not just more than an interface, the user interface, a conversion, a chatbot interface. Then that interface is built on top of GPT. GPT is the branding for the model from OpenAI. Google has their own, Meta have their own, and those are creating on top of the technology. The underlying technology is the large language model. So I put that because LLM is like the yogurt, GPT is like the branding that you are doing, the Danone, you know, and finally ChatGPT is the format that they are providing to us that model, right? So what for me is very interesting is that those models make a very simple thing. They predict the next most probable word in a sentence, right? So that's the same that we had with WhatsApp messages when we started some years ago. I started to send, you put my Taylor and then provide some next word, then sometimes it's something funny, sometimes it's something weird. How is that starting to work much better? Because first of all, it's because of the context. How much words the model is taking into account for predicting the next word, right? So is that context is increasing to being bigger. If we have all the phrase and my Taylor is rich, right? So that's something that is much probable that the model is predicting right. And not only creating bigger and bigger context, but also putting attention on some words over others. So not all the words are equally important for predicting the next. That's the base of technology, the transformers. You talk about the T in GPT is transformer, and that base is attention, right? And those contexts are being bigger and bigger and bigger. Right now we're when you're using normal ChatGPT, you're about 20,000 words in that context, right? And when I'm using context here, there are some similarity with the prompt. The prompt is a kind of context when you are executing the model. When you are using ChatGPT, that prompt that you are writing there is the context. The other thing, this is one, right? Increasing context. The other thing is the training data. The training data is increasingly in a way that you cannot handle in your mind. GPT-3, there is the model in the summer of 2020. That's in the previous era, right? In just 3 years ago. In GPT, they used all the Wikipedia for less than 1% of the data, right? So the amount of data used for training those is amazing. What happened with using so much data? The first thing is there one thing, they understand syntax. And that's pretty normal. That's very expected. The second thing is that, and that's unexpected, and that's because of the volume, is that it started to understand the meaning of the words. We have, in our language, we have concepts there, right? We are thinking through the language. It's not just using the language to communicate, we're using the language to think. So there is something more there. Nothing magical, but it's something more there, right? So with that volume, start to create a kind of semantic meaning, conceptual meaning of the words. So, for instance, there is a relationship between king and queen. There is the same relationship between men and woman, and the same relationship between, in Spanish, hombre y mujer, right? So that's the reason that translates so well, those models, because it's not because of the language, it's because there is a higher level there, right? So we can think that there, with that amount of data, that amount of relationship, that billions of weights that they say, right, when they publish a new model, we can think that they are creating a kind of conceptual model of the world, or something similar to that in that line. And that's very important, because what is probably counterintuitive is that generative AI, the most important thing is not language generation, is language understanding. And that's its very basic and that's the basis, that's the reason that it's so profoundly transforming in so many things. For instance, and there is a difference between using the data training, when you try something with ChatGPT, or using the context, the prompt. For instance, if you ask ChatGPT a summary or any question about Romeo and Juliet from Shakespeare, it's very probable that hallucinates, that invents something, right? Because he's using the training data. In the training data, it's not for answering, not for generating, it's for understanding. But if you put Romeo and Juliet text in the prompt, in the context, it's not going to hallucinate. It's not going to invent anything, right? So there is a difference here on when is inventing, when is not. So what happened with the data used for the training? There is poor quality, and I know that I'm going to be controversial here, but this is all that Rosa says, that is garbage in, garbage out is true, but there is some subtle difference here in those new models. So garbage in, garbage out is true. You have fake news on the training data from GPT, sure, you have it, and you don't care. So for the first time, is more important quantity than quality. And this is mind-blowing. This is something that is changing what we have learned from the beginning of machine learning and all of this stuff. And the reason is that what you care about is that understanding the meaning, not generating any through. If you are using ChatGPT or those models for writing through, you are using those badly, right? So the key thing is that understanding the language. So that's one. And the other is not about the quality, but the problem is moving to the copyright of the text used in the training. This is something that is still to be regulated, how, if the copyright affects or not to that kind of use. And there are different views on that. And that's it, basically. Yes, my idea was just that, putting a base for the conversation.
Thank you very much, José Luis. So now we are going to start asking questions to our experts. With your permission, I will start asking questions, and then any of you can ask. So starting for the last, José Luis. Hello. Do you just said that in these large language models, quantity is more important than quality? But what happens is that quantity is wrong. What happens is that you are using a great amount of data that is wrong? What happens then?
Is wrong in what sense? I mean,
It's fake.
It's fake, no problem.
Why?
That's because if it is wrong because the language is bad format, it affects a lot, right? Because you are not creating that. But if there are fake news, last night we have different views of the same even, but really you don't care, because the problem is what is the use that you're using with those models. If you are using those models to obtain some truth, you're using it bad, right? So the thing is that what you are trying to do with those is understand the language and understand very well. So the way to use them is using the prompt, using the context to provide the information on which you want the model to work on, right? And this is the difference on that. That's the reason also that, for instance, if you put translation in the data, translation between different languages that is bad, this is going to affect, right? In that case, it's going to affect, but you cannot rely on that the information is correct, right? That's.
Emilia?
Thank you. So I will just comment a little bit on the quality of the data, the quantity, and the role of building knowledge with these large language models. I always associate the large language models as the new dictionaries. In the past, when we had Larousse, Robert, we had different opinions. Even on the same languages, we had different types of dictionaries. The academy one, the university one, where there was consensus among the trusted people, linguists, anthropologists, which work on the language. Now with the large language models, with these new databases, we can have, as you mentioned, hallucinations. And hallucinations is taking pieces of information from two contexts, different contexts, quantum physics, and the relation with mathematics, with probability and statistics. You will find common words, common notion, but they have nothing to do together, and that generates a hallucination. The risk which comes with that, because the Artificial Intelligence Act is a risk-based approach, is an educational risk. We have many SMEs which provide educational resources, and it's not only SMEs, the public authorities, they provide educational resources. The risk is that we build the knowledge of the next generation based on hallucinations, and we don't even know which hallucinations they will include. That's one part of it. Then another risk for the business, for the resilience of our society, the economical resilience, is that we introduce risks on the market that we are unaware by not having any control points. Of course, we should evolve. And we should have, as I'm really also for innovation and passionate about that. But we should do it, of course, in a responsible way. We trust what we understand, and now we understand based on the knowledge we received from the educational systems that we have. Of course, it evolves in Charlemagne, and we have the Bologna Convention, 3 + 2 + 3, and that's a formalism we accept. How do we evolve in making this knowledge bases available for society in a responsible manner with control points? Can we check all the hallucinations? Can we check if the truth which were fed in those initial databases were generated by engineers or were generated by engineers which were put in a position of omniscient, knowing about art, knowing about legal? Engineers are building these databases. I'm coming from computer science. So we are using that. I worked with the Atomic Energy Commission in NASA with different contexts, but I always worked with the knowledge and trust from those specialists in the area. We have no guarantee that that happened, but that's not a reason that we should stop that evolution. We should see how to find a compromise, that trust is built, because artificial intelligence passed through different winters. We had high expectations, and now we think general purpose AI. We do have approximation algorithms. We do have the same paradigm since the 20s. The neural networks, fuzzy networks, all these different particle methods, Feynman-Clark theory, all this, they exist. Now we have the computational power, and we are in a brute force approach. Let's make it knowledge and not only brute force trial, isn't it? But I do agree, this is a powerful tool. Thank you.
And imagine that you want to take the advantage of using web scraping of a lot of business, and then you have to analyze all the information provided by the scrapping. Then most of the algorithms that work with words or with language have serious computational problems to work with a big amount of data. Then, in this case, if you want to, for example, make clustering of business for investment or something else, it's very important the quantity and the quality of the data. It's not only, it's not so simple to take in consideration a huge quantity of data. That in that sense, it's important the volume of the data.
So now, anyone can intervene? Yes, please.
Yes, I wanted to expand on what Jose Luis just said. From my own experiments that I have made, is that I really employed like an LLM model, but I improved it with what they call retrieval augmented generation, RAG, where you like generate a knowledge base which the model can then explore and extract information from to provide you really with true information. And when employed in that way, they can really cite information exactly as they appear in the data. They can already find correspondences between different texts. I worked on a corpus from URLX, for example, so a case law from the Court of Justice. And even on a very constrained model, on a very constrained computer, so it's not a huge infrastructure, the results were already very interesting, just by having a basic model, but having it being made able to retrieve information under this RIG method.
Thank you very much. Anyone else? Then, Rosa. Oh, sorry.
Yes, just to build a bit on the quality discussion, or quality versus quantity discussion. It's emerging that we really have two sources of quality. We have the big uncontrolled language models that give us the quality in terms of the syntax, the grammar, a clear storyline in a longer article. And we have the factual quality, and that factual quality does not come from uncontrolled massive inputs, but the factual quality comes from curated inputs, regardless whether I supply them as a knowledge base, as was just mentioned from the audience, or whether I supply it in the prompt. The big challenge that we have is that the syntax, the linguistic quality, creates the illusion of factual quality. That's the one big challenge. And the second big challenge that we have is we in the room, we care about factual quality. But if you put yourself into the shoes of a bad actor, someone on the dark side, who wants to flood the digital space with fakes, with disinformation, with posts that just create some nervousness or some panic, you don't care about factual quality. You can use a large language model that just generates quantity that is linguistically believable and creates the illusion of factual quality. You don't have to worry about the knowledge base. And so all of us here in the room, we're at a disadvantage compared to the bad actors. And that's one of the reasons why we need to think beyond just AI quality when we talk about the challenges.
Thank you, Sebastian. Yes, Emilia.
May I just add one remark? We were mentioning here about, and we discussed a lot about how knowledge is being built. And the example from the room was really nice in the sense that there are mitigation measures. And we have, and we mentioned the Artificial Intelligence AI Act, but we have also the AI Liability Directive. There are so many unknown risks. We can control what we can identify and what we can define as risk. And then we search for the probability of that risk and what are the common countermeasures. But there are so many risks which we can't define, so that we can't mitigate now. For that, there is the AI Liability Directive, and as SMEs, we are really thankful that the stakeholders are really clearly identified when risks will occur and when they need to be mitigated and action being taken upon. Thank you.
Yes, just one comment because no, I agree with Rosa that quality is important. I mean, if everything is garbage, it's going to be hallucinations all the time. It's just putting on the it's not so important as we have been used to use the qualities, and as Sebastian said, how happened that control is in ChatGPT, for instance, there is. As you say, there is a post-processing control that is based on human feedback. So if you try to ask ChatGPT, tell me a racist joke, it's going to say no. I cannot do that, right? And it's because there is a bias, a control bias on top of the model. So that is the way to try. I mean, and obviously we're just scratching the surface of those models, right? So, and what can they do, and what problems they're going to provide. So, but yeah, we're much more closer than I just tried to provoke.
Yes.
I'm going to make a question. To what extent are you thinking about, for instance, to identify some criteria to select the data with the levels, the adequate levels of quality and the amount of data you will need to train this type of algorithms? Maybe this can help you if you focus the selection of data from a business-driven point of view, right? You can focus more on what you want to produce just to get some better result.
Yeah, but first of all, what I do not believe that is that like the old times that I mean 5 years ago. Sorry. Yeah. That we can thinking of creating a model from scratch. I believe that's. I mean, there are very few players that can create a model from scratch. Can be the European Union, can be, but there are Microsoft, Google, Meta, and Arabia Saudita, no? And so those are China. Those are the ones that are creating the foundational models. That is how they are being called. And then you have to to work on top of those. So makes sense if you want to do something specialized, very specialized, for instance, health, language, or legal language or something like that. Try to do, it's called fine tuning. That is a retraining of those models, of those foundational models. But you need the initial volume. You need that because if not, they are not going to work so well, right?
So maybe I'm going to rephrase the question. What about making a more data governed training of the data? This is the point is data governance of the data that you are going to use, just selecting, just establishing some criteria.
Hello, thank you. First of all, thank you very much for the panelists. Very inspirational talk. And this is Javier. I'm my company, Predicland. We work applying artificial intelligence to business and institutions and so on. And one thing regarding quality is not so bad. If you don't have quality, then you have the opportunity to have good quality. Most of the projects, when you start, you don't have the quality enough to really guarantee the good results. But then, if the sensors are not working fine or whatever device that is collecting data, then it is the opportunity to change them to get the correct data. Okay, and then regarding the quantity and the quality, it is not matter of quality, of quantity. You have at the beginning to consider all the relevant data that it is impacting on your analytic, and then afterwards you have to do the debugging of those data just to have the essential data that is impacting really in the analytic you are going to perform. So there is a data science process behind, Rosa will know, and all of you will know, and that is really ensuring that when you have the final solution, the quality of the data is guaranteed. Okay? But not always at the very beginning of the project you have that. Okay? Even for the sensors, even because there is noise in the data, bias, and so on. It is work of the scientific people working on that, the data scientists, to just get the correct signals to get the proper predictive analytic. Okay, just wondering to add a little bit.
Thank you. Here, let's first, no,
Yes, thank you. Yeah, just only to put this in the floor. Okay, how can we use IA to detect this in the process? Okay, I put a lot of information. Okay, for the base. Why don't help us to detect these things and don't produce? How to reuse this information to solve this problem? Just only why not? Okay. What, maybe because it's unsolved problem at this moment, or can we use this process to process and don't produce this kind of information?
There are two ways of that. One is there are some tools, especially for universities, right? Because you have a in the last Christmas you have a big bang, right, on the ChatGPT and work from the students done by ChatGPT, and then appear some tools that you can check if a text is generated by ChatGPT or not. But well, it's not possible. It's not possible because you can say to ChatGPT, generate a text like I'm 5 years old, or like I'm 15 years old, or like I'm an expert, or like I'm a writer on the 15th century, or generate a text that is not detectable. So it's pretty original. So basically, is not possible. That's one point. And the other was how was the? No. The
why don't we use ChatGPT to correct ChatGPT or small models.
And the other that is more related with that question is that you can use the model to check the answer, the same model. For instance, you can say, generate a tweet about that with that style, because it's the style for one big company, and generate the tweet. But you can do the opposite. You can do, is that tweet following the style? And it's checking both, right? So there is a lot of techniques that we're starting with that. So but techniques that the same model is doing the verification.
I have read the ChatGPT, use ChatGPT before they give the results. So ChatGPT 3 to ChatGPT 4.
Check it, check it both, yeah.
I will go a little bit differently on this issue. Of course, we can agree to disagree. And my perspective, of course, on that is there are tools from the universities, Stanford, Harvard, and so on. They develop tools to check creative writing. But on free speech, checking whether this is factually true, this is a perspective, it's a subjective perspective. So it will be really difficult in creative writing to identify whether that was generated, although this is not impossible. It will not be bulletproof, it will not be 100% of the cases, it's approximation techniques. We check the generated output of approximation techniques, but they exist. Many of the universities, they develop that. Not 100% sure, approximation techniques. Then I would go also on the fact that there are big players which develop these systems, and it's not new. 20 years ago, when we had search engines, large language models were used, not in the open like we have it now, and you interact with that, but search engines are based on that. This is not new. It's not only in the open to the end public. And then going on that paradigm, we think that, okay, big tech can make big investments. We are 4 to 5 million SMEs in small business standards. If we all put 100 euros, it's enough to start this kind of project. It's a pragmatic way. You just need to start it, no? And then we think about the artificial intelligence algorithms, the implementation. Europe had a really quintessential project, AI for Europe. In AI for Europe, all the implementation of all available artificial intelligence algorithms, which are used by big players and small players alike, are available for free. This is not an open source platform. Open source platform, they can have sponsorship behind, and then they are somehow proprietary to one specific company, let's say, or entity. But AI for Europe, it's a publicly developed, publicly maintained, neutrally maintained platform. So we have that. We have European data spaces. European data spaces allow concentration, sectorial concentration. We do not have general artificial intelligence. We have artificial intelligence which can be sectorially, and knowledge which is sectorially valid. We are already building that. It's not in the open, it doesn't use big words, but European data space are a reality. They take time. They take real data. They need the collaboration of all industry alike. They need interoperability, the reason we are here. They need data quality issued by collective reasoning by us all, isn't it? So there is hope. And the fact that there were big investments from some big players in this area, that means there is a need for them also to return on investment. So that systems, they are not stable on the market in the sense that if there is a competitor coming from Europe, a neutral competitor, that could play the same role. Nobody wins the market. And the models that we see, the general models that where we chat, these are not the economically true models. The economical true models are the specialized one. They are specialized version, like I will not cite the names of the specialized version because I'm not bounded by any of those. One in the legal domain. They have partnership with big corporates. And those partnerships, they start being a return on investment. And this is real value, because if you are going in the legal domain, you use legal text, and you train your model only on that context, and you do not pretend this is creative writing. It's only legal. I'm feeding you factual through data and factual through synthesizing of those data. This kind of model can be built on European data spaces. And I think the European AI strategy has all these elements, so we should be confident on what we have. It will take time. Economical impact takes time because it takes adoption and takes the end user trust. And they trust what they understand. And I think educational purposes, which are part of the artificial intelligence strategy, are quintessentially understanding there are alternatives. We have a small project in Luxembourg where we have school teachers which are invited by the Digital Media Center to critically test all these platforms which are chat-like, and to give their opinion, professors in history, professors in mathematics, professors in different fields. And then they will be able to help kids navigate with critical thinking those, and do not consider them as ground truth. There's just a parenthesis, a small example. Huh?
Thank you. Then yes. Go.
Hello. It's a kind of change of topic. If you don't mind, I would like to talk about fairness and who and how decide what is fair. Thank you very much.
Yeah, this is a very typical question when we work with companies, because if who is the evolution of the machine learning algorithms, so that there is examples in which the prediction are very biased, depending on any variables that can be important for us. For example, race or sex or status civils or something else. Then the evolution of the algorithms allows us to test the output and then evaluate the bias. This is very important. But the second question is how to define the fairness, or how variables is important, depend on the problem. If you are working with a bank, they are very worried about some kind of variables. If you working with health, the variables change. Then depend on the problem. The idea is that if you are able to create a methodology in which you are compare the distribution of the groups that the algorithm is able to split, then you are able to reduce the bias. It's impossible to reduce at the end. And another thing is because in the current literature about bias, the problem is that they attack one only variable. What occurs when you want to combine more than one variable? This is one of the problems that we are now faced. But this is very, very new problems in this kind of methods.
And when you think you are enough fair, I mean, what do you want? You want an algorithm and a model that is fair or that is exact? Because at the end,
depend on the objective that you want with the algorithm, or depend on the problems. Is fair? Exact is not the objective of our research. The idea is to reduce the bias produced from some variables. This is fair.
at the end, sorry, just one word. At the end, you change the word and you say bias instead of fair. And what I was trying to get is to bias and not fair, because at the end,
but
we are not talking about fairness. We are talking about bias.
Yeah, but when the variables are very related with very fashion words,
it is better to talk about fair. Okay, thank you very much.
Sebastian, please.
I would give an answer that is maybe even more extreme, but it will be deeply unsatisfactory. But I think it's the right answer. I don't think that fairness is a technical category. I don't think that we can ever say this system, this AI system, is objectively fair, because fairness is a political decision or a societal decision. Simple things like, is it fair to give every student at school the same level of support, or is it fair to give weaker students more support than stronger students so that you have equal outcomes at the end? there is no objective answer to that. It's a negotiation process. So the question we can then ask, well, in relation to fairness, what is left that we can answer on a more technical level and that we can also answer in standardization? And it's really two things. We can of course standardize various fairness metrics, so mathematical metrics, representative metrics, all sorts of ingredients that play a role in fairness. We can also standardize the way in which we describe the outcome of the political process or the political decision. And in fact, I led a consortium in the past 2 years that created an AI trust standard, an AI trust label, and we had fairness as one of the categories. And although everywhere else in the label, when we talk about transparency and accountability, we had clear, hard product-related criteria, for fairness, the requirement was nothing to do with the product. It was to be able to prove that you've had a certain type of stakeholder dialogue, that you document your conclusions in a certain way, because there is no objective answer to is this system fair or not.
Thank you very much. Well, it is 3:30, so it is the end of the session, and we have only one question on Slido, which is bravo. Bravo.